This last lesson for our chapter is dealing with functions and inverses, and now we're going to say, okay, once you have a function and its inverse, we're going to compose it. Remember, this is one of the special types of combinations we saw. Compositions are when you see things like f of g of x. That's what we meant by composition. We're going to do that with functions and inverses. So to review, here's a function. We're going to find the inverse. Remember, to find an inverse, you need to swap the x and the y. When you're looking at a function, this f of x here, that is the y. So this is really saying y equals 5x plus 11. So to find the inverse, when we switch these, we will say x and y equals 5y plus 11. Move your 11 over. So x minus 11 equals 5y. And then divide both sides by 5. So the inverse here will be y equals x minus 11 over 5. And remember, we saw a special notation last lesson that had f negative 1. That's our special way of saying the inverse function, x minus 11 over 5. So this is the original right here, and this down here is the inverse. Okay. So now that we've remembered how to find inverses, we're going to compose. So when you see this f negative 1 here, it's referring to the inverse, and we see regular f, that's referring to the original up here. So find f inverse of fx. We're going to rewrite this. Remember, we can rewrite this to be f inverse of, and on the inside we'll put the fx. So write your big function first, this one in red. In red we have this guy, which is space minus 11 over 5. That's the inverse, and into that we're going to input the original, and the original function is 5x plus 11. Let's simplify this. When we simplify this, we see that positive 11 and negative 11 will cancel, so we end up getting 5x over 5. 5x over 5 cancels, and so we're just left with x. So this one here equaled x. Let's do the other one over here. This one switches the order up a little bit. This one has f of f inverse of x, so the blue function is our original, and into that we will input the inverse. So we'll write our blue one nice and big, which is 5 blank plus 11. Input the inverse, which is x minus 11 over 5. Now when we simplify this, 5 times this, these 5's can cancel. So we're left with x minus 11 plus 11. The 11's will cancel, and we're just left with x. So one of the things we want to notice then is that when we did the inverse first, or whether we did the regular function first, no matter which one went inside, we ended up with x for both of them because everything canceled. It's the inverse. Or in other words, everything was undone, right? And we said that's one of the things about inverses. Inverses undo things. And here we saw that inverses in the regular functions undid everything, so that we ended up with just plain x at the bottom. So let's do some of these with numbers then. Let's do f inverse of f of x with a 7. So again, this is the outer one. And then inside is the f, and inside of that is the 7. So remember, to do these, we do the inside part first. So f of 7 means that we have 5 times 7 plus 11. 5 times 7 is 35. 35 plus 11 is 46. We take that 46 and we plug it into the red one. So we have f inverse of 46, which we saw was 46 minus 11 all over 5. 46 minus 11 is 35 over 5. 35 divided by 5 is 7. So notice this. We started with a 7 and we ended with a 7. Just the same way that we started here with an x and we ended with an x. Started with an x, ended with an x. Let's do another one. We're going to do f inverse of f, whoops, sorry, different color, f of 3. Do the inside part first. So the inside part, f of 3, is 5 times 3 plus 11. 5 times 3 is 15, plus 11 is 26. So f inverse of 26 is 26 minus 11 over 5. 26 minus 11 is 15 over 5. 15 over 5 is 3. Again, notice we ended with 3, we started with 3. Hopefully by now you're seeing the pattern. We've seen that the inverse of a function with the function undoes everything, right? That's our key word here. The inverses undo things. They take you back to the beginning. Okay? Back to the beginning is our big idea. Back to the beginning. So, for us, as we're looking at something like this one, it has a really big number here. We see that we have the inverse, and we see that we have the original. And so we go, I know that when I combine inverses with original, I'm just going to end up with that same number. So we can skip and say negative 5208. So our big idea for today is that when you compose, remember that special of language here, when you compose a function and its inverse, you should always end up with the original output. Always end up with the original input. Always, always, always. So if you start with an x, you'll end up with an x. If you start with a 7, you'll end with a 7. The original input is what you will always get.